Hello, good people. This is Trockers. Welcome back to my channel. We have a problem on complex numbers expressed in polar form, and we are also going to apply the De Moivre's theorem to solve this problem. Right. It's a ZIMSEC November 2004 paper 2 problem, which reads, a complex number z has modulus of 8 and argument pi over 4. Another complex number w has modulus 1/2 and argument pi over 8. Write in each of the following complex numbers in the form a plus ib. 1, we have zw to the 4th power, z squared over w squared. Find the smallest value of n such that the modulus of w to the nth power is less than 0.01, and this problem was allocated in total about 15 points. Right, so guys, first things first here, we need to rewrite that polar form in modulus argument form, or in, we need to rewrite this complex number in modulus argument form. Since we are given the moduli and the arguments for both complex numbers, right? And what else do we need to do? Okay, cool. Then we have to apply the De Moivre's theorem and its properties. All right, so without wasting much time, let's go ahead and get started. Okay, so a complex number z is modulus 8 and argument pi over 4. So z, or maybe let me write it here, z is equal to r, which is 8, right? Then cos theta, which is pi over 4, plus I sine pi over 4. Then my w is equal to 8, right? Modulus is 1/2. Then this is cos, my angle is pi over 8 plus I sine pi over 8. Okay, guys, so for brevity, I'm not going to write this in full. I'm going to say cis, right? So it's r cis theta, right? Where r is your 8, c is for cos, imaginary part, sine, then theta, whatever the angle it is, so that I don't waste much of the time here. Okay, so first we need to find zw to the 4, right? So my z here is that one, so you just say 8 cis pi over 4 being multiplied to my w, which is 1/2 cis pi over 8, but this is to the 4th power, right? So guys, the De Moivre's theorem states that if z is equal to r, then cos theta plus I sine theta, then z to the n is equal to r to the n, then here it's cos n theta plus I sine n theta. So the exponent will affect the angle, but here it affects r directly. So we are going to raise r to that exponent. So this is exactly what we are going to do here. It's going to be 8 cis pi over 4, then 1/2 to that power, it's 1 over 16, then cis here. So this 4 is going to multiply the pi over 8, and we remain with pi over 2, because I'm saying pi over 4, pi over 8 times 4, which is just pi over 2. Then here, it will be 8 over 16, then cis. So when we multiply two complex numbers together, you only add exponents, right? You add the angle. So for example, if I have cos pi over 4 plus I sine pi over 4 being multiplied to cos pi over 2 plus I sine pi over 2. Here, the rule is that you just have to add. You sum these two together. You sum up these two together, then you do the same plus I sine you sum these up again, right? So that's how we simplify it. So I'll go ahead here and simplify. I'll go ahead and simplify that part. Okay, this one here, this one here becomes 1/2. Let me say this what? If I say pi over 4 plus 1/2, that's 3 pi over 4. Okay, so this is 3 pi over 4. But remember, we are supposed to express this in rectangular form. So I need to see cos 3 pi over 4. So make sure your calculator is in radians. So cos 270, cos 3 pi over 4, I'm getting negative square root of 2 over 2 plus, I don't know, sine 3 pi over 4, I'm getting root 2 over 2. So I root 2 over 2. So when I distribute the 1/2, it becomes negative root 2 over 4 plus I root 2 over 4. Right, just leave it in exact form. Yes, you can express that in decimal form, but just leave it there. So guys, that's how we find ZW to the 4th power. So now we need to move on to the other part, which is item 2. So on item 2, we are requested to write here z squared over w squared. So again, my z, it's 8, so you can just say 8 says pi over 4 to the 2nd power over 1/2 says pi over 8 or to the 2nd power again. Then remember, this affects your r is normal, so my modular squared is 64. Then this one here becomes pi over 2 over this one here, it's now 1/4, right? Cis pi over 4, right? So if you divide directly 64 and this is just 64 times 4, it becomes 256. So this is 256, right, cis. So here, when you divide, you subtract, right? When you divide, we subtract, so we remain with pi over 4. So it's 256 cis pi over 4. And now it's 256. Remember, we need to express that in rectangular form. So cos sine pi over 4 sine 45 degrees should be the same as cos. All right, it's root 2 over 2. So this is root 2 over 2 plus, I believe this is root 2 over 2 again for cos. Let me double check. I mean for sine. Pi over 4. Yeah, right. Then if I distribute the 256, what do I get? Right, 256 divided by 2, 128. So it becomes 128 square root of 2 plus I 128 root of 2. Right. So guys, that's how we find z squared over w squared. What was important here is to subtract the angles. So when you're dividing two complex numbers that are expressed in polar form, go ahead and subtract the angles, right? If you multiply, you sum them up. Okay, now we have last part. So last part of the question, which is B, find the smallest number. We need to find the smallest number, find the smallest value of n such that modulus of w to the n is less than 0.01, right? But remember, we are told that the modulus is 1/2. So we want to solve this, right? Is less than that. So when you have inequalities of this kind, go ahead and introduce logs. So you can introduce ln or you can introduce logs. So I'll just go ahead and introduce natural logs on both sides. Then here, if you bring this down in front of that, it becomes n natural log of 1/2 less than natural log of 0.01. So every time you divide with a smaller number here, or with a negative number, not a smaller percent, but with a negative number, because natural log of a fraction is negative, you invert the sign. So it's 0.01 over ln 1/2. So n will be greater than. So here, when I say natural logarithm, okay, so natural logarithm of 0.01 divided by natural logarithm of that, okay, I'm getting 6.643856. So therefore, the smallest number of n will be 7. So if you are to raise this 1/2 to the 7th power, so if we say 1/2 to the 7th power, just okay. So when I say 1/2 to the 7th power here, I just want to see. So you can say 1/2 to the 7th, then you can say 1/2 to the 6th power. What do we get here? Okay, when I say 0.5 to the 7th power, 0.5 expressed to the 7th power here. All right, so I'm getting 0.00782125. Then if I express that, to the 6th power here, I'm getting 0.0156, right? So we want it to be less than 0.01. Here it's more than, because it's 0.02, but here it's now 0.008, which is less. So in order for this inequality, for this modulus to the nth power be less than 0.01, the smallest number here will be 7, right? So we are done, guys. I'm signing out.